of arterial blood. This will be a review of arterial blood gases. Make sure everybody's on the same page. So we look at the arterial blood gas. There are some values that we'll measure. Okay, the first value that you want to look at is the pH. Okay, what is the pH a measurement of?
Hydrogen ions.
There you go. Yeah, it's a measure of hydrogen or hydronium ions or protons. And what we do is when we measure hydrogen ions, or hydronium ions actually is the better term, but whatever, it's all the same thing. When we measure them, we actually measure them in moles per liter. So if I measure, let's say that I have a liter of blood plasma, and within that liter I have 10 to the negative 7 moles per liter. Okay, so I have 10 to the negative 7 of a mole, and a mole is 10 to the 24 atoms, or 6.02 times 10 to the 24 atoms. These numbers are rather inconvenient, right? These really tiny and really large numbers are rather inconvenient. So what I do is I just take the negative logarithm, okay, because this is negative here, right? Negative 7, right? We're talking about a very small fraction of a mole. I take the negative logarithm of this, base 10, so the negative log, and the negative log of 10 to the negative 7 is 7. And the negative log of the hydrogen ion measurement is the pH. So when your acid is, your hydronium ion concentration is 10 to the negative 7 moles per liter, that's actually a pH of 7. That's what the 7 means. And if I have 10 to the negative 6 moles per liter, negative 6 is a larger number than negative 7, right? It's actually 10 times larger, right? Because as my negatives are getting closer to 0, they're getting larger, right? Okay, so that's 10 times larger. Well, what's the negative log base 10 of negative 6? 6, right? So a pH of 6 is 10 times more acidic than a pH of 7. Likewise, if I have 10 to the negative 8 moles per liter, that's going to be a pH, the negative log pH of 8, right? This is smaller, right? So this is 10 times less acidic. So 8 is 10 times less acidic, or 10 times more basic than 7. And then it's another 10 times than 6. Does that kind of make sense how that works? Okay. So when we look at the normal pH in the human body, we have a range that's considered normal. And then we have a value that is considered normal. So we have a normal range and a normal value. We have to have a range because of the uncertainty in our machines. There's a little bit of wiggle room there in how they measure. So the normal pH is 7.4. 7.40 is perfectly normal. But we allow a little fudge factor, if you will, from 7.35 to 7.45. All right? Anything less than 7.35 is considered acidic as far as the body's concerned. And anything greater than 7.45 is considered alkalotic. Does that kind of make sense there? Okay. So that's my pH. And then I have my PaO2, which is my measurement of oxygen. It doesn't really tell me anything about my acid-base balance, though, right? I don't look at my oxygen to figure out my acid-base balance. And what's a normal PaO2? Normal range? 80 to 100 millimeters of mercury. It's a pressure. Okay, and 90 is my perfectly normal. Okay, now I have my PaCO2. That's the partial pressure carbon dioxide in the blood, right? And what is the normal range for PaCO2? 35 to 45 millimeters of mercury. And the normal PaCO2 is 40. And then I have my bicarbonate, HCO3 negative. And bicarbonate has a normal range of 22 to 26. And what's the normal value? Right in the middle, 24. Okay, is everybody okay so far there? Now, we need to realize what means what. So a low pH is more acidic, right? A higher pH is more basic. A low CO2, however, is basic. Okay?
Okay.
This is, people really get messed up here, okay? Carbon dioxide is an acid. Just think of that. CO2 is an acid. Okay? So if I get rid of CO2, my pH should go up, right? Getting rid of an acid is going to make me more basic, right? So the thing I do is just get that in your mind that carbon dioxide is an acid, even though it doesn't have any hydrogen in it at all. And we'll talk about why that is, why it actually is an acid. Okay, so a high CO2 is going to give us a low pH. Does that make sense? Because it is an acid. A low CO2 is going to give us a high pH. Does that make sense? Okay, the CO2 looks at the respiratory component of acid-base. Okay, it looks at the respiratory. And there is a saying known as Rome. Rome. And that saying stands for respiratory, opposite, metabolic, equal. What do I mean by that? Respiratory opposite is a low CO2 correlates with a high pH. They move in opposite directions. Does that make sense?
So
My
it's
pH, respiratory opposite. So as my CO2 goes down, my respiratory, as I blow off CO2, my pH will go up. And as my CO2 goes up, my pH will go down. Does that make sense? That the pH and CO2 are opposite in the way that they go up and down. They are inversely related. And the bicarb looks at the metabolic component. And metabolic equal. So a low bicarb is going to correspond with a low pH. And a high bicarb is going to correspond with a high pH. So bicarbonate and pH will move in the same direction. Does that make sense? So respiratory opposite, metabolic equal. Does that make sense?
Yeah.
That's a major mix-up when people look at ABGs. They always, especially that carbon dioxide. So when we look at how we transport CO2 in the body, so if I have my cell here, and out of the Krebs cycle, carbon dioxide is produced, right? So I'm breaking pyruvic acid down, I'm tearing carbons off of it. I have carbons and oxygens left over, becomes CO2. So CO2 comes out of the cells, and if we look at the structure of the CO2, it's carbon, double bond to oxygen, it's linear, it's nonpolar, it's not charged. Electrons aren't distributed, they're distributed more or less equally. Nonpolar molecules, like CO2, don't dissolve in water very well, just like fat. You ever try to dissolve oil in water? Does it happen? Not very well, because fat is nonpolar. Fat is a lot like carbon dioxide. It doesn't dissolve in water. Well, that's inconvenient because I need to get that CO2 through a whole lot of water to get it out of the body, right? Can I dissolve it in the blood? No. So I have to turn this CO2 into something that will dissolve in the blood. Does that kind of make sense? So what I do is, I have an enzyme called carbonic anhydrase. And that enzyme helps convert carbon dioxide. So carbon dioxide combines with a water molecule, okay? And that creates a hydrogen ion and a bicarbonate ion, okay? Are these charged? Yeah. Do charged particles dissolve in water real easily? Heck yeah. So now I've turned that CO2 into acid, right? Because there's my hydrogen ion there, right? Now this can be transported, and once this gets to the lungs, carbonic anhydrase comes along and helps combine the H2O plus the H plus the HCO3 to create CO2 again, right? And then the carbon dioxide is an exhale Does that kind of make sense? Does that kind of make sense there? Now there's an intermediate molecule when the CO2 and H2O combines called H2CO3 or carbonic acid.
Right.
But it's very unstable and it breaks down into this stuff so quickly that, I just go straight to this here. Does that make sense?
Mm-hmm.
So that's why carbon dioxide is an acid. It has to be turned into an acid so we can transport it. Okay. So that's why when the CO2 increases, the pH will decrease.
And that's why predominantly most of your waste products aren't on the hemoglobin, but are actually within the plasma and whatnot itself, and then come back, correct?
Actually, you can bind a fair amount of CO2 to the hemoglobin.
I thought this stuff,
It's called carbaminohemoglobin.
I know, but I was thinking that when we were, last semester, when we were teaching it in pathophys,
Mhm.
we were showing the students, that it actually said that it's not, that instead of, like you always think, all the CO2 goes on, that a vast majority of it is
Oh, yeah,
transported.
yeah.
That's
Yeah,
Transport
70%. Yeah, 70-80% of
That's
your
what-
carbon dioxide is transported as hydrogen ions. Yeah. Okay, so I'm going to give you guys a couple of examples of gases, and I'll show you how I work through them. You may have a different way of doing it that works better for you. That's okay. So let's do this here. Don't start interpreting quite until I get all the stuff up here. All right. So the first thing I do when I look at an arterial blood gas is I look at the pH, and I ask myself, is it acid, is it base, or is it normal?
Acid.
I just put a little A there. And then I move down, I'll move to the CO2. Is it acid, base, or normal?
Acid.
It's acid because it's elevated, right? Bicarb, acid, base, or normal?
It's
Normal.
normal.
Okay. Okay, so now what I do is I connect the dots. I know that there's acidosis. What's causing the acidosis? Is it the respiratory or metabolic? Respiratory. So are you guys so far okay with calling this a respiratory acidosis?
Yes, because now you can correct it by just correct. You can correct acidosis by
Maybe correcting that. Are we done though? Is this it? Is that it? Or is there something else we need to identify?
your O2 saturation.
Yeah, we look at our O2, and I just took that out because it doesn't tell us anything about the acid base. There we go. We need to see if there's compensation. And the way that I look at compensation is, once I identify what my problem is, so in this case, respiratory is a problem, right? So what I do is I think of respiratory metabolic as buddies that go to the bar, okay? These two guys go to the bar and they get drunk, okay? They get totally wasted. And respiratory gets into a fight. He's in a fight right now, right? And he's getting his butt kicked. He's abnormal, right? He's getting his butt kicked. And what I ask myself is, did his buddy, in this case, metabolic, jump in to help out? No, because it's normal, right? If his buddy was helping out, this would be elevated, right? To try to compensate for the acid. In this case, his buddy's just sitting there watching him get beat up. So in that case, we call that uncompensated respiratory acidosis. Does that kind of make sense?
Yeah.
Okay. So let's.
So it goes up at like 30 to be compensated respiratory.
There you go. It would be partially compensated because the pH is still abnormal. Yeah.
So true compensated.
Fully compensated, and I'm getting there actually. I'm going to give you guys a couple of examples. Okay, so there's that. Let's do. Okay, so again, start at the pH. Acid, base, or normal? 7.3 is it's acid, right? Acid, base, or normal? Base, because it's low. Bicarb, acid, base, or normal? Acid. So connect the dots. What is this? This is a metabolic acidosis. Is there compensation?
Correct. There is compensation.
Yes. right? His buddy jumped in and helped out. Did they get the job done though? Negative, right? So this is a partially compensated metabolic acidosis.
So this is something that we cannot correct with respiratory corrections alone, right?
Maybe, maybe not.
I mean, we have to drop his respiratory even lower.
Or you need, no, his respiratory rate need to be higher. He needs to
Higher,
be
sorry.
faster, deeper. Yeah. You might be able to. This is a good example of like a DKA patient. Someone has DKA.
Yeah, something we can't correct, we're just trying to modify his respiratory, right?
You're not going to completely correct it. Yeah. Not. I mean, not this. Yeah, it's a metabolic.
Yeah, it's gonna take.
But would you want to slow that rate down or make him breathe shallower?
No.
No, you'd want to keep that compensation there. Yeah. Okay. Let's do a couple more. So CO2. Let's make. Okay. So pH
pH is normal.
is normal, but is it on the acid side or base side of normal?
Acid side.
Okay, so I'll just put like a little A, acid normal, okay? It's in the normal range, but it's on the acid side of normal. CO2, acid base normal.
It's gonna be a acid.
It's acid because it's elevated, right? Bicarb, acid base or normal.
It's gonna be base.
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 So what would we call this?
We're gonna call this-
Compensated. Respiratory acidosis.
There we go, right? So in this case, the pH is normal, which is barely, right? Just barely normal. And is it acid or basic normal?
Acid.
It's acid normal. Would it be normal if metabolic wasn't chipping in? No, right? It wouldn't be. So what's the cause? Well, it's acid, right? Because these two A's line up. So we would call this a fully compensated respiratory acidosis. Does that make sense? Okay. All right. Let's do something completely different now. So. Okay. So pH, acid, base, or that's 7.49.
Base.
Base.
Base. CO2, acid, base, or normal.
It's gonna be,
Base.
Remember, respiratory opposite.
it's opposite, so it's base as
Base, right? Bicarb, acid, base, or normal. Normal. So this is a
well.
Respiratory alkalosis.
respiratory, right?
Non-compensated.
Uncompensated, right? Yeah. There you go. Uncompensated. So it's uncompensated respiratory alkalosis. Okay. Maybe someone's having an anxiety attack or hyperventilating, you have some sort of injury. Okay. Right. Let's see here. Let's do this here. Okay, what do we have here? Acid, base, or normal?
Base.
Base. Acid, base, or normal?
Base.
Base. Acid, base, or normal?
That's acidic.
Acid. So what's going on here?
Decompensated respiratory.
Okay, so do we have a respiratory,
It's a mix.
Alkalosis.
okay, do the B's add up, guys?
Yes.
Okay, so this is, remember, CO2 is respiratory. So this is a respiratory alkalosis.
It's partially compensated.
There we go, right? In this case, the bicarb is going down to compensate, right? Didn't get the job done, so we call it a partially compensated respiratory alkalosis. That kind of makes sense there. All right. Let's see here. Let's do one of these here. Acid, base, or normal?
Acid.
Acid. Acid, base, or normal?
Acid.
would be
Acid, right?
Acid.
PaCO2.
It's elevated, right?
Elevated, so it's acid.
There we go. Acid, base, or normal?
Acid.
Acid. The heck is this?
Dead.
They're all acid. What's that?
Feeling elevated at all.
What do we call that?
Uncompensated.
Uncompensated.
Uncompensated, respiratory, metabolic.
Okay, so connect the dots. Is it an acidosis?
Right.
Yes.
Okay, so it's an acidosis. What do we call it when it's both a respiratory and an anabolic? Mixed. We call that a mixed acidosis.
Let's go to deep water.
That's not good, right? Mixed acidosis is generally not a good deal at all. All right, does that kind of help out a little bit there with ABGs? Yeah, that's really all there is to it.